I would like to welcome Sarah Sondag from Minnesota DOT. Sarah will be talking about the unmanned aircraft systems, UAS, in the Metro District Bridge Inspection implementation.
So first, I just want to say that I am presenting on behalf of our State Bridge Inspection Engineer, Jennifer Wells, who is unable to be here. So please, only easy questions, okay? So I'm just going to talk a little bit about the project background. We have a phased research project going on. Talk about some of our drone applications, the funding and tasks and timeline associated with the project, some information about some of the equipment we're looking to purchase, some examples of field work, lessons learned, and next steps within that project. MNDOT partnered with Collins Engineers for a phased research project that began in 2015. The first phase really looked at feasibility and cost effectiveness of bridge inspection utilizing drones. We just recently completed phase 3. There is a report on our website, research page website. The next phase is implementing, specifically within our Metro District. We also received a STIC grant, so State Transportation Innovation Council grant, to assist with even promoting that implementation statewide. So we learned from previous phases of this research that bridge inspection utilizing drones can be cost effective. This is a cost savings analysis from phase 3 of that project. And this is based on bridges that are suitable for drone inspections. It can't be applied across the whole bridge network. If you don't see a cost savings, you can still see some quality gains in the form of data that's received. And in addition, there could be an extension of life because you could make a better decision because you had better data to support that decision. In addition, you can see more cost savings where traffic control and access equipment can be eliminated. So in areas where you might need to utilize under-bridge inspection vehicles or rope access, drones can potentially help with savings. It cannot replace a hands-on inspection, but it can be another tool for access. So as I mentioned, we realize that drone inspections can have cost effectiveness associated with them, but they also can provide successful data. So we can detect deficiencies and conditions through the use of drones. We can document those deficiencies and communicate those deficiencies, and I'll show some different ways that we can communicate those. The emphasis now, though, is on implementation. How do we collect that data? How do we store that data? Which bridges do we use drones to inspect? Especially in the form of how do we package that data and present it so that we can make better data-driven decisions. The project manager on this project is Jennifer Wells, as I mentioned earlier. As part of some of the initial phases, we also looked at equipment. So it's important that this inspection-specific drones, that they have object sensing, that they're capable of looking up, so you can look underneath the bridge decks, that you can fly without GPS. We had some that we initially utilized, and once you flew under the bridge deck, we lost GPS signal, and so they flew back home, which doesn't really help us when we're trying to perform a bridge inspection. We need drones that can provide good photo resolution, video, thermal imaging, and also some drones that can be utilized in confined spaces. We can also use AeroPoint ground control to obtain even more accurate data, survey quality data for 3D modeling. The next few slides will show just some of the examples of drone data presented in some different formats. This is a screenshot from Pix4D, which is a post-processing software that we've utilized within this project. And on the left side of the screen, you can see kind of all the points within the map that's representing all the photos that were taken with the drone. And then the photos, you can see on the right-hand side of the screen. Each time you can pick within that map, and then your photos will show on that right side. And within those photos, we can add annotation. We can utilize this data then to even create a 3D map. And within that map, you can take measurements, you can annotate, you can write notes, and it can better kind of represent what the deficiencies are on your bridge. We can also combine drone data with other technology. So this is an example of an underwater blue view scan that was combined with drone data from above the waterline to represent the pier. We can also use drones for management of other assets like roadway signs, overhead signs, and monuments. It can also be used in emergency situations. In this case, this was a rock slide in Wabasha. Specifically for this project, the funding comes from 3 different sources. $100,000 was the federal STIC grant, $25,000 state match that came from our scientific equipment budget, and $100,000 of research money. And that research money is specific for phase 4, which is implementing in our Metro District. But the STIC grant will help us kind of implement even broader than our metro district to statewide application. Some of the tasks within this implementation project include creating a DISC, a drone inspection subcommittee. And members on the committee are within our bridge office, our districts, aeronautics office, FHWA, consultants, and local agencies interested in utilizing drone inspections. As part of that, one of the deliverables will be an operations manual, and within that manual it will include pre-planning, preparation, on-site procedures, pre-flight checklists, emergency procedures, accident reporting, and all the laws and policies surrounding utilizing drones. We also want to come up with a drone bridge list and appropriate inspection frequencies. So it might be similar to bridges you assign an underwater inspection to, or bridges where you have to assign snooper access to, right? So we want to identify those bridges within the inventory for MnDOT bridges, for local agencies bridges within Minnesota, where drone inspection might be a good option for access. But it also be dependent on access issues. It could also be dependent on condition. So we're going to develop that criteria. So looking at purchasing equipment for our bridge office and for our districts. I'll go into detail a little bit in the next few slides. Implementing field training, conducting field work, and then a final report, which will be completed in June of 2020. Current equipment that has been utilized on the project, and it's a combination of MnDOT-owned and consultant-owned through Collins Engineers. So the Flyability Helios, which is necessary for confined space. That's the drone you see at the top with the cage. Both Collins and MnDOT own an Helios drone. The SenseFly Albris, which is now obsolete and being replaced by the Intel Falcon. These are your commercial level drones, so a little bit higher priced, your $20,000 to $35,000 drones. Benefits are, larger sensor size, higher resolution cameras, more reliable, they have dual batteries, durable, and they're specifically built for bridge inspection. So like we talked about, they can look up underneath. One drone that we are looking at purchasing as part of this project is the DJI Matrice, and that one also is built for bridge inspection. It can look up, it can be, and we're looking at utilizing that, managed through our bridge office and utilized for 3D modeling. We're also looking at some consumer level drones. So these are smaller priced, lower cost options, more effective for our districts to manage for routine inspections. These types of drones, they can't fully look up, but they can look up at an angle about 30 degrees. And so if you angle it correctly, then you can look at the underdeck. Like I mentioned, they're lower cost, but they're smaller size. They can be transported easily, right? More readily used by our district staff. And they can still provide really high quality imaging. And you can put thermal cameras on these as well. It's not just the drones, you need all accessories too, right? So this is a Crystal Sky monitor for the controllers. It's ultra bright. It can work in extreme temperatures, and it's interchangeable between all the drones. So like I mentioned before, on some of the consumer level drones, this is the DJI Mavic, and then I mentioned the Matrice. So we're looking at DJI at this point because it's the same manufacturer. This type of monitor is interchangeable on those drones. We also can interchange the batteries and some of the other components. So that's why we're looking at utilizing the same manufacturer. First-person vision goggles. So these kind of put you in first person like you are on the drone. You're viewing what the drone is seeing. They fit over glasses, they're very light to wear, and it has head tracking. So you move your head, you can turn the drone. But if you're utilizing these, you have to have someone else in line of sight of the drone at all times. Other things you might need to think about: cases, batteries, data links, HDMI cables. Here are some other cost-effective drones that we looked at part of this project, but like I mentioned earlier, we're going with looking at purchasing the DJI models. Even more to think about, right? Not just the drones and their accessories, but how are you going to store the data? How are you going to process the data? You need supercomputers, post-processing software. Then there's licensing, registration, insurance, right? So every drone needs to be flied by a commercial pilot. You need FAA registration. We have MnDOT registration, insurance. Again, it's a fleet, right? It's a fleet of equipment, so we need to treat it as such. And then you have extra batteries, external hard drives, power cords, communication devices, right? A lot to think of. Here's an example of how all that adds up. If you notice, so this is looking at purchasing another Helios, a couple of Falcon 8s, some of the smaller consumer level drones, our post-processing software, some pilot licenses, registration, insurance, and field supplies. Well, we're already over our budget. So we had to kind of rethink. We're now looking at just going with the DJI Matrice, like I mentioned, for the bridge office, and some additional smaller consumer level drones for our districts. Timeline for the project, so we're right in that field work and field training development stage. The next phase will be finalizing the operation manual. And then the report, as I mentioned, is due in June of 2020. I mentioned this earlier, the goal is to develop a bridge drone list for Minnesota bridges. We're starting with our access policy. So there are times when the typical means of access is not enough to satisfy NBAS for routine inspections. So you may need additional access to actually completely define what that condition is or if there's any change in that condition. Traditionally, we've looked at, right, get a ladder out, get an underbridge inspection vehicle. You may have to go to rope access. But drone is another tool to be able to provide that service, right? It's another access tool. As I mentioned before, it doesn't replace hands-on, but it's an access tool to be able to get up and take pictures, video, high quality resolution that you can actually measure with, that type of photo. Part of this project then will kind of refine that criteria for that drone list. Part of Metro's implementation, we selected bridges within the metro area, and we tried different drones on different types of structures and kind of tried to figure out what works best. For example, in cases of tight access, like beam ends and bearings on high wall abutments, you may need a certain type of drone, like a confined access drone like the Elios, which we see a lot in our metro area, which is why our metro district purchased the Elios. For your larger, more complex structures, then we might look at different reporting tools, right? So maybe you can do some autonomous flying with larger drones like the Falcon 8 or the Matrice, and then you can provide an orthomosaic map, or photo, which is basically just an aerial photo that's been geometrically corrected so the scale is uniform so that you can take true measurements on it. Or you can use it to develop point clouds. And within those point clouds, then the deficiencies can be documented. So you can kind of see all the little tags, the deficiency tags. It's very important to be able to communicate your data quickly and efficiently and also spatially. Some of the benefits, we know there's safety improvements for both our inspectors and the public because we're not actually closing a lane, right, for drone inspections. Improved access for some of those areas, some of those tight areas like high wall abutments, large bridges over water. Quality gains in the terms of the data, but of course you also get a lot of data on that side, right? So you can see that picture on the top is a photo of the drone over Jen as she is marking some cracks on St. Croix River crossing. And below that you can see the actual cracks that she's mapping. That's a photo from the drone. We talked about the cost savings. There's also reduced public impact, right? We talked about not closing the lane. And it can assist with those data-driven decisions, especially when you get to your more complex structures, or maybe they're at a level of condition where you need some sort of a management plan. So you might need more data to appropriately manage that throughout its life. Some more of the challenges, it's a learning curve, a lot of training. Also, we have to have some acceptance. It's not a hands-on inspection, right? And it won't replace your hands-on inspection. But it is an opportunity to get into access in areas that you can't see, right, traditionally with binoculars, or it's harder to access with a snooper. And you can get a good idea of what that condition is and where you need to focus your efforts. There's a lot of rules and regulations and there's a lot of data. So figuring out how to store that and present it in a way and use it on bridges that make sense, right? Those are the keys. Some next steps, as I mentioned, we're developing the UAS operation manual as part of this project. We'll purchase equipment, perform statewide training, which is already underway. We have some of our districts now that are licensed pilots. Develop the drone list inspection list criteria, or at least finalize that, and then publish the final report in June. So more to come. Thank you. Any easy questions?
How much more office time do you see reviewing video?
I guess I can't answer that because I haven't been the one reviewing the information, but it is definitely more intensive to review it. And we have not, like I said, we're looking at implementing it on a statewide level and determining which bridges it makes the most sense to do a drone inspection on, because you do get so much more data, right? So it makes more sense on some of our complex bridges where we're trying to develop a management plan for, or a repair plan for that's a little more intense than maybe what your regular repair plan might be.
Is your report going to have some like study, whether you want to do it in-house or by consultant, say? Do you have the study, or you decided to go in-house right away?
So the research project started as a partnership, like I mentioned, with Collins Engineers. So most of our drone inspection to date has been through consultants. I think depending on what type of drone you need, what type of data you want out of the inspection may determine if you perform it in-house or if you go out with a consultant. Or, for example, if you use a consultant for determining the management plan, maybe that's part of that same contract. We are looking right now at implementing the drones on a routine inspection level within our districts using the consumer level drones, right? And we're going to have one drone in-house in the bridge office, the Matrice, for 3D modeling. So we're starting out smaller, and then within the Metro District, we knew we had a lot of instances of confined space access, so we do have a confined space drone within the Metro District. So we're really in the initial phases, so we might, hopefully that will come out a little bit within that research project report.
How the defects are quantified? Is it something after post-processing, or it's done during the collecting the data?
I believe mostly post-processing. So the data, the photographs are taken, and within the post-processing software, then the photos are stitched together and the 3D modeling happens at that point. Yeah, so those arrow point targets, ground targets, are really important for getting that survey level quality information so that you can measure. I think it's within 1 centimeter. Paul, maybe you have a response on the, I'm gonna bring Paul up. No, just on, you've used some of the drone information for projects, or at least the PIX 4D information for projects. Some benefits you've seen? Or?
Very minimally. Collins Engineers was they were in charge of a substructure survey, finding out where DLAM was, and we had 120 piers that they were hammer sounding, and so they were using the drone to just take images of all the outlines on the pier caps and create a record so that we'd be able to quantify unsound concrete. And that could be done with a deck too, if they chain it and mark out areas so that you can program your project to understand quantities and then just run the drone over and you have a record of what you got.
So that's an example of actually marking out, like hammer sounding or chain dragging, marking it out so you have a known kind of quantity of defects, but it's along the whole deck or along multiple piers. You can quantify it with the drone, and the quantities can be measured from the 3D models that are created.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.